Good morning. I am Pooja Bhanot, lecturing chemistry from Pandit Jagatram Polytechnic College, Hoshiarpur. Today I am going to deliver a lecture on basic concepts of chemistry. So let us discuss what is chemistry. Chemistry may be defined as the branch of science which deals with study of composition, structure and properties of matter and the changes which the matter undergoes under different conditions and the laws which governs these changes. So, what is chemistry? As we all know, this is a branch of science which deals with the study of composition, structure and properties of matter. You all know what is matter. Matter is anything which occupies space and has volume. What are the different branches of chemistry? There are different branches. The names are given on this slide. The first is inorganic chemistry, organic chemistry, then physical chemistry, then analytical chemistry, biochemistry, pharmaceutical chemistry and industrial chemistry. I will give you just an idea that what these chemistries are about. So, inorganic chemistry is the branch of chemistry which deals with the elements other than carbon. So, these elements or their compounds, they are mainly derived from inorganic objects. So, what is organic chemistry? Organic chemistry is the branch of science which deals with the study of carbon and its compounds. So, mainly they are derived from animal and plant. So, the organic compounds are basically the compounds which are derived from animals or plants. So, organic chemistry is the study of carbon and its compounds. What is physical chemistry? Physical chemistry is the study of fundamental physical phenomena of nature. What is analytical chemistry? Analytical chemistry is the estimation and the detection of different elements and compounds which are present in nature or they are synthesized in laboratories. So, what is biochemistry? Biochemistry is the branch of chemistry which deals with the chemical changes occurring during the life processes. What is pharmaceutical chemistry? Pharmaceutical chemistry is the study of drugs and medicines. Industrial chemistry. Industrial chemistry is the branch of science or branch of chemistry which deals with the production of chemical species or compounds on large scale. So, in brief, I have discussed that what are the different types of chemistries. So, I hope that you have understood these different branches of chemistry. Now, we will discuss in detail that what are units and dimensions. So, let us discuss a term that is physical quantities. So, as we all know that chemistry is an experimental science. So, in our day to day life we used to measure different quantities like mass, temperature, time, etc. So, all these quantities which we come across during scientific studies is called physical quantity. So, physical quantity is the any quantity which can be measured. So, these quantities are measured in terms of certain standard reference. So, what are units? The measurement of any physical quantity consists of two parts. As we all know that if we want to measure the length, then we express the length in meters, or we are want to express this, then it will be, if some certain rope or certain cloth is there, then we will say that it is of 2 meters or it is of 3 meters. So, what is the measurement of a physical quantity? It consists of two parts. One is number, second one is unit. For example, if we want to express the mass, then it will be in kilogram, that is the unit, and what is the number, that is 2.5. So, what is unit? Unit may be defined as a standard reference chosen to measure any physical quantity. So, what is a unit? Unit is a standard reference. So, what are physical quantities? It is very clear from this slide that any quantity like mass, length and time which we can measure, that is known as a physical quantity. And if we want to measure it, then it consists of two parts. The measurement consists of two parts. One is number, second one is unit. So, unit is a standard reference. There are different types of units. One is fundamental unit, second is derived unit. So, let us discuss what is fundamental unit. Fundamental units are those units which can neither be derived nor resolved into any other unit. So, what are fundamental units? These are the units which cannot be derived or neither they can be broken into any other unit. So, what are the mass, length and time, they are the fundamental physical quantities and their units are known as fundamental units. First of all, the mass, length and time were only considered as the fundamental units, fundamental quantities, and the units were considered as the fundamental units. But later on, according to SI system, that is the system international, there are 7 basic units. So, first of all, we have considered only 3 fundamental quantities and the units were called fundamental units. But later on, this system international, that is SI system of units, considered these 7 basic units and there are 7 basic physical quantities, fundamental physical quantities. First is length, second is mass, third is time, fourth is electric current, fifth is temperature, sixth is amount, 7 is luminous intensity. So, what are their SI units and what are the symbols? As you can see in this table, that length is having the SI unit, that is meter, and its symbol is small m. Mass is having the unit kilogram, so its symbol is kg. Time is having the unit second and symbol is small s. Electric current, the unit is ampere and the symbol is A. Temperature is having Kelvin, so the symbol is K. The amount, that is in mole, the symbol is mol. Luminous intensity, the unit is candela and the symbol is CD. So, these are the fundamental units and their quantities are known as fundamental quantities. What are derived units? The units of all such quantities which can be expressed in terms of fundamental units of mass, length and time are called derived units. So, what are derived units? The units of all the quantities which can be expressed in the terms of fundamental quantities, that is mass, length and time. For example, area. So, what is its relation with other basic quantities? This is length square. So, its unit become meter square. So, this is derived. This has been derived from length, because the formula of area is length into breadth, both are having the dimensions in length. So, length into length, that is m into m, that is m square. Volume, that is length cube, so unit is meter cube. Velocity, that is meter per second and the unit is meter per second. Let us discuss that what are the dimensions of the physical quantity. The dimensions of the physical quantity may be defined as the powers to which the fundamental units of mass, length and time are raised to obtain the units. The units of mass, length and time are denoted by bracketed capital letters, that is capital brackets capital M, capital L, capital T respectively. So, what are the dimensions? Dimensions are the powers to which the fundamental units of mass and length time are raised to obtain the units. And how we write these units, that is in terms of capital M, capital L and capital T. Dimensional formula. What is dimensional formula? As I have already explained that what are the dimensions? Dimensions are the powers to which the fundamental units of mass, length and time are raised in order to derive a unit. So, then what is a dimensional formula? Dimensional formula is an expression which shows how and which of the fundamental units enter into the unit of a physical quantity. For example, what is the dimensional formula of area? This is m raised to power 0, length raised to power 2, t raised to power 0. So, what is the dimensional formula? Let us consider the physical quantity, that is area. What is the unit of area? This is length into breadth, that means it is having the dimensions in length. So, length into length, that is length square. So, it is not having mass and time in its formula. So, what are the dimensions of mass and time? That will be 0 because it is having 0 dimensions in mass and 0 dimensions in time, and there are 2 dimensions in length. So, what the formula becomes? Formula is m raised to power 0, L raised to power 2, T raised to power 0. So, dimensional formula is an expression. This is an expression which shows how and which of the fundamental units enter into the unit of a physical quantity. So, I have discussed the two new definitions, what is dimensions and then what is dimensional formula. Now, I am going to discuss what is matter. Matter is anything which occupies space and has volume, or which can be felt by one of our 5 senses. So, there are 2 types of classifications of matter. One is physical classification and second one is chemical classification. So, what are the states of matter? You have all heard that there are 3 states of matter, but later on it is added that there is 4th state of matter also. So, what are these? One is solid, second one is liquid, third is gas and fourth one is plasma. So, these are the 4 states of matter according to the physical classification. What is the chemical classification of matter? Matter, as you can see in this slide, you can see here in this flow chart that basically there are 2 types of matter which according to chemical classification, which are further divided into different types. So, what type of matter is mixture? Mixture is having variable composition that I will discuss later on. And second type of matter is pure substances. They are having constant composition. So, the mixture is further divided into heterogeneous mixture and homogeneous mixture. Pure substances, they are further of two types. One is elements, second is compounds. Let us discuss all these types of matter in detail. Now, you can see in this flow chart that the matter is of two types. One is pure substances, second one is impure substances. Impure substances are called mixtures, and pure substances, they are further of two types. One is elements, second one is compounds. Let us discuss what is an element. An element is a substance composed of same type of atoms. For example, gold, oxygen, these are elements. So, what is an element? Element is a pure substance which is having its own physical and chemical properties and which can neither be broken into nor it can be built up from simpler substances. So, element is a pure substance. It is made up of same type of atoms, and you can give the more examples of elements also. Hydrogen is the element, carbon is the element, oxygen is the element. So, there are near about 118 elements in the periodic table. So, what is a compound? Let us discuss. After discussing that what is an element, let us discuss that what is a compound. A compound is a substance made up of more than one type of atoms. For example, water, that is H2O, carbon dioxide, that is CO2. So, what is a compound? Compound is also a pure substance, that is very clear from this graph that this is also a pure substance which is made up of two or more elements combined together in a fixed proportion by weight. So, what is the meaning of a fixed proportion? That means, if the two elements or the three elements, they are combining in a fixed proportion, then only that particular compound will be formed. For example, I have written here in this slide that water is a compound. So, what is the ratio? What is the ratio of hydrogen and oxygen? This is 1:8. And if this ratio changes, this is a fixed ratio. If the hydrogen and oxygen, they are combining in this ratio, that is 1:8, then only water will be formed. And if this ratio changes, then the compound also changes. For example, in the case of hydrogen peroxide, the same two elements, that is hydrogen and oxygen, they are combining, but they are in different ratio, that is 1:32. So, a different compound is formed. So, if the elements, that is hydrogen and oxygen, they are combining in this particular ratio, that is 1:8, then only water will be formed. So, what is a compound? Compound is a substance which is made up of more than one type of atoms, or we can define it that this is a pure substance which is made up of two or more elements combined together in a fixed proportion by weight. Further, I am going to discuss here that what are the types of elements. There are three types of elements, you all know there are three types of elements. One is metal, second one is non-metal, and third one is metalloid. What are the types of compound? There are two types of compounds. One is ionic compound and second one is covalent compound. What is mixture? So, I have discussed in the flow chart that there are two types of matter. One is pure substances and in the second category lies the impure substances. So, what are the mixtures? Mixtures are the impure substances. So, the combination of two or more elements or compounds in any proportion by weight is called a mixture. So, if you are combining two or more elements or compounds in any ratio, because in compound the elements they are combining in a fixed ratio. So, here in mixture you can combine them in any ratio, that is a mixture. That is, for example, if you are combining the nails made up of iron, you are mixing them with sand. So, they can be mixed in any ratio and that is a mixture, and this can be separated by physical and chemical methods. So, what are the two types of mixtures? One is homogeneous mixture, second is heterogeneous mixture. What do you mean by homogeneous? Homo means same and hetero means different. Homogeneous mixture, they are having uniform composition throughout and the components are present in one phase. While in the case of heterogeneous mixture, the components are combined, which are combining, they are present in different phases. So, homogeneous mixture, basically these mixtures, the homogeneous mixtures are solutions. Now, I am coming to the next point, that is symbol of element. What is symbol? You have seen that hydrogen is written as H. So, its symbol is H. So, what is symbol? Symbol is a shorthand notation used for the full name of the element. For example, the symbol of hydrogen is H, the symbol of carbon is C, the symbol of calcium is Ca, the symbol of cadmium is Cd, and the symbol of sodium is Na. So, how we have decided these symbols? We have used different rules. For some elements, we have taken the first letter of their name, that is, like you can see here that hydrogen, the symbol is H, that is the first letter of its name. Then symbol of carbon is C, it is starting with C, so the symbol is C. But if another element which is again starting with C comes, then what we have followed? We have taken first two letters. First letter is capital and second letter is small. Then again another element is coming, then we have taken first and the third element, like in the case of cadmium, we have taken capital C and small d. Again, if some elements are left, then we have also used their Latin names. For example, the name of sodium is natrium, so their symbol is Na. The symbol of calcium is, the symbol of potassium is K, because their Latin name is kalium. What is an element? What is an atom? What is atom? Atom is the smallest unit of all the matter, that is composed of three subatomic particles called protons, electrons and neutrons. So, what is an atom? Atom is the smallest unit which takes part in chemical combination, and this atom may or may not have independent existence. For example, as we all know that oxygen is present not in atomic form because it does not have any independent existence, it exists in nature in the form of O2. But there are some noble gases like helium, neon, argon, they can exist in their atomic form. That means the atom is the smallest particle which may or may not have independent existence. So, it is very clear from this topic that what is atom? Atom is the smallest unit which take part in chemical combination, and it may or may not have independent existence. What are the subatomic particles of an atom? One particle is proton, you have heard about this, one is electron, third one is neutron. What is a proton? Proton is the heavy, positively charged particle in the nucleus of an atom. Electron, the very light, negatively charged particle that orbits the nucleus of an atom, that means it revolves around the nucleus. So, what is a neutron? Neutron is the heavy, but it is uncharged particle in the nucleus of an atom. The uncharged or unreacted atoms have the same number of positive protons and negative electrons. That means, in case of atom which is uncharged or which is not reacted, the number of protons and number of electrons are equal. What if we are talking about the approximate size of an atom, then we will say that millions of atoms, you can see from this statement that millions of atoms could fit on the sharp point of a needle. Also, if you imagine then an atom is the size of an oval, a proton and neutron would be the size of footballs in the middle of the oval, and the electrons would be in the size of rice grain racing around the running lane. So, you can well imagine that what is the size of atom, then what will be the size of proton, neutron and electron. What is an atom? A molecule and ion. I have already discussed. Then what is an atom? Atom is the smallest particle of an element which may or may not have independent existence. I have also quoted some examples here that which of the elements occurring in nature which are having independent existence and which are not occurring in nature independently. All the noble gases, they are occurring independently, rest of the elements, they are not present independently. So, in what form they are present? If I am saying that oxygen is not present in its atomic form, then in what form they are present? If one oxygen atom is combining with another oxygen atom, then there will be the formation of a molecule. So, what is a molecule? Molecule is a smallest particle of either an element or a compound. So, molecule is the smallest particle, but it is having independent existence. So, what is the difference between the definitions? What is the atoms may or may not have independent existence, but the molecules they have the independent existence, because oxygen is not present in its atomic form, but it can be present in its molecular form which is more stable. So, there are two types of molecules. One is homoatomic, second one is heteroatomic. Homoatomic molecules, they are having same atoms present in the molecule. So, what are heteroatomic molecules? They are having different atoms in their molecules. Then we are coming to the point that what are ions? I have explained you that what are atoms, then I explain to you what are molecules, then I am going to discuss that what are ions.